This is the second set of notes in the ES8 Freshwater Resources Unit, and it's called ES8.2 Soil Formation. As usual with these notes, I'd like you to write down everything that is in orange text, and you can either type it or handwrite it. Either way, it's going in your digital science notebook. If you feel like I'm moving too fast at any point, feel free to pause the video. A lot of things go into the formation of soil, but it all starts with the weathering of rock. Add in some organisms and some organic matter. Mix in the rock with that organic matter and the sediment, and you get soil. And the process takes a while. It creates layers that are also called soil horizons. And water plays a big role in the formation of soil. As water moves through terrestrial environments, it plays an important role in the formation of soil. Soil is a mixture of organic matter, clay, and weathered rock fragments. It is formed from the weathering of rocks and organic activity. Soil has spaces between the sediment, and air and water can get inside of soil. Here is a distinct picture of some layers of soil. You can see as we move from top to bottom, it goes from a dark brown to kind of a sandy color. At the top, there's going to be more nutrients for plants and animals, and at the bottom, there's going to be less. If we went into the nearest field and dug a deep hole, you'd find the soil in layers. These layers of soil are sometimes called soil horizons. There are 6 soil horizons that you need to know. The O horizon, or the organic horizon, that's living things and surface litter. The A horizon, also known as topsoil, this contains decaying organisms and rich organic matter, also known as humus. The E horizon, E stands for eluviated. This is the bottom of the A horizon. It's less fertile and has been leached. Leached means the nutrients have been removed. The B horizon, or subsoil, that's a mixture of sand, silt, and clay. There's virtually no air at this level and no life. The C horizon, which is also known as regolith, is partially weathered bedrock. And then the bottom is bedrock, which is the impermeable layer. Impermeable means no water can pass through. It's unweathered, solid parent material. And here are 2 different diagrams of those soil horizons that you should know. We'll be drawing this as well. As we move from top to bottom through the soil layers, organic matter decreases, the amount of living things decrease, nutrients and minerals decrease, and weathering decreases because exposure decreases. So at the top you have more life and it's more exposed to the elements. Different ecosystems are going to have different kinds of soil. The soil you find in the forest is much different than the soil you will find in the desert. The forest soil will be much richer in organic matter and contain a lot of humus. That's the dark, rich organic matter. This is kind of a crazy erosion picture. As it moves through a watershed, water causes weathering, erosion, transport, and deposition of rocky materials. Weathering is the process by which rocks are broken down chemically and physically by the action of water, air, and organisms. Erosion is the process of carrying those small pieces away. The four agents of erosion are wind, water, ice, and gravity. Weathering and erosion turns rock into sediment. Sediment is small particles like dirt, silt, and clay. Transport is how the sediments are carried by water to streams and rivers and eventually to a large body of water. Deposition is the process by which earth materials carried by wind, water, or ice settle out and are left in another location, such as the bottom of a lake or ocean. So, when exposed to wind and water, rocky materials are weathered, eroded, transported, and deposited in that order. Here's a picture of a stream moving some sediments along. Some of it's dissolved, some of it's not. There are two types of weathering, chemical and physical. This picture has physical weathering on the left and chemical weathering on the right. Chemical weathering is the dissolving of certain types of rocks by rainwater. All rainwater is naturally slightly acidic, meaning it has a pH lower than 7. This allows it to dissolve certain minerals inside of rock. Chemical weathering can also come from oxidation of minerals exposed to air. Here's some examples of chemical weathering. On the left we have a sinkhole that apparently opened up underneath of some cars. And on the right we have a rock that's being dissolved by water. Physical weathering. Physical weathering is the breakdown of rock by mechanical processes. That means motion and friction. Physical weathering can be caused by running water, wind, living organisms, or ice. Plants and animals can be agents of physical weathering by interacting with rocks and soil. Frost wedging is a form of physical weathering. It's how ice weathers rocks. Water fills the cracks between the rocks, and if the temperature gets low enough, the water freezes. Since water expands when it freezes, this contributes to the breakdown of rock. So while it's still liquid, water fills a crevice, and then when water freezes, it expands. It's a unique property of water, and it makes the hole a little bigger. Here is a photographic example of frost wedging. So for the next couple of slides, we're going to look at some pictures and decide whether the erosion is physical or chemical. So whenever an organism is involved, such as this burrowing owl, it's going to be physical. Motion and friction of this organism's body caused that erosion. Might be a little hard to see what's going on in this picture, but we have a tree trunk growing up through some rocks. That is also physical because it's due to an organism. All right, and that is everything for this set of notes. Here is the catch-all slide with everything that you need to have written down about soil formation. Thanks, and have a great day.